Would you like to learn about AWS Transit Gateway, AWS Direct Connect Gateway, and AWS Virtual Private Gateways? If so, this video is for you. Hi, I'm Mike Gibbs, and in today's video, we're going to talk about what is AWS Transit Gateway, as well as AWS Direct Connect Gateway and AWS Virtual Private Gateway. And then we will discuss how we will use AWS Transit Gateway, as well as AWS Direct Connect Gateways, as well as AWS Virtual Private Gateways in your cloud network architectures. And we're going to begin by discussing Transit Gateway. And Transit Gateway really is just a router, like any other router, that enables you to use hub and spoke architectures on the cloud. So if we look at the Transit Gateway and we remember that it's really just a router, it's going to be a lot easier for us to think about it. So, and I'm going to map it out architecturally in a minute. I just want to talk about why we use it. It's going to make our network architectures much simpler, and I'm going to walk you through how that is architecturally. We use Transit Gateway to enable hub and spoke models, and I'm going to show you what that actually means. And we use it to significantly simplify routing. Now, I said a lot of words, so let's map it out architecturally, and let's talk about the complexities that we would have with Transit Gateway and without it. So the first thing I want to remind you is that routing as a rule, and a cloud provider is what's called non-transitive. Now, if any of you are network architects like I was, and you've got a lot of time with BGP, this is going to feel a lot like internal BGP. But if you've not been a network architect before, let's talk about what non-transitive means. What non-transitive routing really means is, let's say we've got a VPC A over here. And VPC A is, or Virtual Private Cloud VNet, if you're on Azure, same thing, is going to be connected to VPC B, VPC C, and VPC D. And that means that this hub environment, VPC A, can talk to VPC B. It can also talk to VPC C, and it can also talk to VPC D. But because it's non-transitive, VPC D cannot talk to VPC C. And VPC-C will not be able to speak to VPC-B. Now, the reason this occurs, and I'll walk you through it with another architectural example, and then at some point we'll go back to Transit Gateway, is this is what we have in a non-transitive environment. If you are directly connected to it with your route peering, you will receive it, which means in this architecture, VPC-A can talk to VPC-B, and VPC-B can talk to VPC-D, and VPC-D can talk to VPC-C, and VPC-C can talk to A. A and D can't talk to each other even though the route's here. So what did we do in IBGP? We would fully mesh our peers, where everybody would have a link to everybody. And if we do this, we fix the problem. However, we have another problem in that, like AWS, for example, will only let you have so many VPC peering sessions. And this reaches this really nasty formula when it comes to connections. And I'll write the formula down for you, and then we'll do an example, and then we'll go back to Transit Gateway. The formula on the number of connections is going to be N, and it's going to be times N minus 1, and we're going to divide that by 2. So let's say in this example, we've got 4 routers, no big deal, or 4 VPCs. So we've got 4 times 4 minus 1, which is 3. So we've got 12 divided by 2, or 6 connections, which you may have noticed. Here's where this gets ugly. Now we have 100 VPCs, which is not a lot. So now the hum number is 100 times 100 minus 1, which is 99 divided by 2. Which is basically, if I do the math in my head, about 44.5. So that's going to be a lot more connections we're needing to deal with. And actually, it's going to end in a 6 or 40. So it's never going to be a half a connection. But you can see exactly how quickly this becomes out of control. And if we go, now we're going to enable Transit Gateway. And look how simple it is. Transit Gateway does the same thing that the BGP route reflector type of environment did, where it says, take AWS's or VPC's A's information, give it to VPC B and give it to VPC C, and then take VPC's information and give it to VPC B and then VPC A. Now VPC A can talk to B and talk to C through this hub. Now, what'll happen is these connections will be made via eBGP, and eBGP as it stands is transitive, whereas iBGP is not. And this gets fairly quick and fairly easy. So that's how it smooths this out, because now we've got 100 of these. We can have 100 of these connect to a single site. And these transit gateways are logical devices versus physical devices. So realistically speaking, they shouldn't go down. Now, it doesn't mean we might not want to have two transit gateways connected to two different links, but keep this in the back of your mind. The other thing that I want you to understand is we can use, we can say have a router here, and the router can be connected to transit gateway and to this transit gateway through another type of a gateway, but they'll be connected to the transit gateway. And that means I have the customer here. The customer can reach any of the VPCs through this transit gateway. So it enables the customer to reach everybody and all your VPCs to talk to each other. So this is a very cool environment to actually want to have these things work. Now that's your typical transit gateway. And it solves that non-transitive routing. It makes it simple and elegant. So now let's talk about what it's going to be like a little more of this transit gateway. If I go back to this architecturally, if you can see what's going on here, this transit gateway is really just a router speaking eBGP to these VPC peering sessions. And if you'd like to learn more about BGP, I will leave a link, and I'll have my team provide a link in the description of this video to our last BGP workshop. It's about 8 hours of BGP training, and I think it'll really help you understand some of this. But that's really what's going on, is it's just functioning as a router here. So it enables this hub and spoke kind of networking thing, gets rid of that non-transitive routing problem, and now we're good. So a little bit about the AWS specifics on this transit gateway, and then we'll get into other gateways, is what's really going on is it's going to connect to your VPC, which you can see, these are your VPCs over here, through what's called an attachment. And what'll happen is the transit gateway will be required to specify a subnet from each availability zone where the traffic's going to be routed. Like in any other routing environment, you need to know what subnets you're going to pass. And when you attach that transit gateway to your VPC, it's going to create an elastic network interface in the right subnet. And that's how it's going to communicate inside of your VPC. So I kind of hope that really helps make that fairly clear over there. And of course, with the transit gateway, we can connect a site-to-site connection, basically connect on-premises environments. We can peer with other transit gateways. And of course, we can also connect to something else on the network. So that's AWS Transit Gateway. Now let's talk about AWS Direct Connect Gateway. Now that's going to be a very useful gateway to talk about, and I want to make sure you understand that. Now, if you have a direct connection to the cloud, meaning a private line, AWS calls it a direct connect, Azure calls it an express route. It's the same kind of private line for the most part we've used for the last 50 years or so, 60 years, an Ethernet-based private line, which is probably 25 years old, but private lines have been around for a long time. Now, when we deal with the AWS Direct Connect Gateway, again, it's going to be functioning as a router. It's going to be a gateway that is going to enable you to connect your on-premise environment through this private line to multiple VPCs across various AW regions, which means it'll enable you to use Direct Connect, one single Direct Connect account in order to reach multiple environments. So let me show you what that actually looks like. If we walk through a typical direct connection architecture, let's talk about some of the things that are actually going on over here. Maybe make this a little bigger for you to be able to see some of these things. Didn't realize I came across a little small. Let's fix that. So here we've got our data center or our campus or wherever our users are. And we've got a router that's going to connect us to this direct connection location. And you may hear it called the direct connection location. You may call it her. You may hear it called a point of presence, which is typically what these data centers that connect multiple service providers are called. And what will happen is you will buy a link from the direct connect from your data center to this direct connect data center. And that will be a router of yours, just as customer edge equipment between you and them. Now, of course, the cloud provider will basically have their device, which goes and plugs back into the cloud provider, and your traffic will be backhauled on that. But that's not the purpose of this video. But in the purpose of this video, we can take our direct connection, and the direct connection will connect to this private virtual interface. And then the direct connect gateway we can use to connect it to multiple VPCs. And that means on this single wire, we can reach multiple locations going back to our data center. Now, this tends to scale fairly well because let's say this is a 100 gig link. Maybe we just add another 100 gig link in a link aggregation group, and now this is 200 gigs. And now we can conceivably connect to these AWS VPCs anywhere we want in the AWS environment. So that's giving us a lot of flexibility. It really is. Now, understand that Direct Connect Gateway by itself is not transitive, which means that this VPC and this VPC over here won't be able to speak to each other through this Direct Connect Gateway. We need Transit Gateway for that. But this provides us a beautiful way to use a single cable to basically connect to large parts of the AWS environment. And that's one of the reasons we like these Direct Connect Gateways. So from a network architecture perspective and a network architect perspective, which is the way I spent most of my life, realistically speaking, this Direct Connect Gateway is just a central point. It's an aggregation point. It enables this hub and spoke connection to the rest of the cloud. Now, what are these links over here? These are the equivalent of almost something like a virtual wire that will be signaled across the cloud provider's network. These are virtual connections, not physical, but they are on the provider's network, not the internet, which means they can guarantee some degree of performance. Now, understand you've got a global reach here. So this is reachable from all public regions except for China. So in this position, while this is US East and I have them both as US East, it could also be US West in two different regions. It can be in a region in Europe, a region in the Middle East, a region in Africa. It doesn't matter. We're getting all that. Now, from a routing complexity perspective, it's just a single BGP peering session that we're setting up. So the routing configuration here is fairly easy. And then we're going to learn routes, obviously, this way. So fairly easy, fairly simple and elegant setup. Now, we can also use with these Direct Connect gateways, we've got this exclusive private virtual interface support. And what that means is that an interface that goes to a private virtual interface like we have here means all of this means on AWS network, not on the public internet. Security and performance. Now, we can link to multi-accounts and multi-regions, what we can do over here. So understand that this is good. Or we may combine it with Transit Gateway. And in a lot of occasions, we're going to need to use Transit Gateway. So if we go back to this, you can see this routing is very simple. I know I've mentioned it a few times. All this kind of network traffic over here is going across the AWS Global Network Backbone, which means they can provide some performance guarantees by knowing what's on their network, which could never occur on the internet, which means we're going to have good performance as well as good availability. And that's what we're typically looking for. So maybe we want to use a Direct Connect gateway to get to the cloud provider and also Transit Gateway to have really cool routing and enable our environment. So let's say, for an example, I've got a company that's got a single link or a link aggregation group to AWS. They've got a big, powerful connection to AWS. Well, with that, maybe they can connect to all parts of their AWS infrastructure. So let's go back to this environment. Now, this link, we have to understand if we're going to use this link as the primary link, This link is going to have to be able to withstand any of the traffic across the AWS environment that needs to come to the customer. So what we could do here is, let's say we had 200 gig links for a company that needs some pretty good bandwidth to their providers. And we can connect our direct connection to this Direct Connect gateway. And then we will connect the Direct Connect gateway to various transit gateways. And that way you could have a transit gateway that's going to route in between all these VPCs in a single region. We can connect to another transit gateway in another region, connecting us to all these VPC environments. So you can see single wire. And now we can use this hub and spoke environment of VPCs on the cloud and connect to them. So this is very, very, very cool. So that's why we might use the both of them together. Now let's talk about an AWS Virtual Private Gateway and what's that used for. So an AWS Virtual Private Gateway is going to be another virtual router, because it's all doing routing type functions, and a gateway is just another term for a router that's going to enable you to connect your AWS VPC to your on-premise through this virtual private gateway. Now, when you connect to a virtual private gateway, it could be a VPN like an IPsec tunnel that you could be using, or it could be a private line that's going to connect to this virtual gateway. So keep that in the back of your mind. And of course, we'll architecturally map this out for you to look at it. So in this first environment, we've got a site-to-site VPN. Now, we've got a customer. They've created an IPsec tunnel. It's hitting this virtual gateway that in some ways is acting as a VPN concentrator. Now we've terminated the connection at the virtual gateway, and then it's going to route the traffic back to your VPC. So that's going to be one of the common environments we might have, as a site-to-site VPN. Why is it a site-to-site? Because it's a customer network going directly to a VPC. One site directly connecting to another. And what you can see is in these architectures, we can further build them out. So we can have a router, for example, that's going to go, and the router is going to be, through its direct connection, will then be connected to, say, a Direct Connect gateway. Now the Direct Connect gateway is going to use this private virtual interface, which is going to connect to a virtual gateway, which is going to go back to our VPC. So there's a lot of ways we're going to use these Direct Connect gateways, and we're going to connect them with our virtual gateways, or IPsec tunnels, and we're going to connect them to their virtual gateways. Now, here's going to be another architectural example. Let me walk through this, maybe clean this up a little bit as we go. And in this architectural example, you can see what we've done is now we've got a router connected to a Direct Connect gateway, and that's got these private interfaces, which we can connect to multiple virtual gateways. That's going to take us to multiple VPCs. So you can see we've got a lot of flexibility here in what we're doing. And even architecturally speaking, we can also create these hub and spoke environments where we've got over here with this virtual gateway, we've got our customer. Maybe they're in Athens, Greece. Maybe the next part of the customer is in Miami. And the third part of the customer network is, say, Sao Paulo, Brazil. And they all connect to these virtual gateways. And that way they can reach AZ1 and AZ2. Now, remember, these virtual gateways are not transitive, which means AZ1 and AZ2, unless you've enabled routing on the cloud, won't be able to talk to each other through the virtual gateway. And these are systems that you'd put in these various availability zones, for example, in your VPCs. But the customer networks won't be able to talk to each other through your virtual gateways either, because they're non-transitive. So this could be a good thing. It could be a bad thing. If what's hosted in these environments is like a partnership, so let's say this was a tire company that was headquartered in this environment, and we were using virtual gateways connecting to other environments, like a brake manufacturer, a tire manufacturer, whatever. We don't want the tire and brake manufacturers talking to each other through the hub, through our network. So sometimes non-transitive routing can be a beautiful thing, and sometimes via route policy, we actually have to set that up. But these are typically how we're talking about putting multiple of these things together. So at the end of the day, Each virtual gateway is going to serve a single VPC. And each VPC can only have one virtual gateway. So to put it another way, once a virtual gateway is going to be attached to a VPC, it can establish multiple VPN tunnels or multiple private line connections. It's going to be a dedicated VPC edge termination. So if you've ever come from the wide area network world, you know you've got that point of demarcation. Well, this is your virtual gateway, your virtual private gateway is your dedicated VPC edge. That's where stuff would be there, the connection point, the edge of it, if you will. Now, there's only going to be one virtual private gateway for your VPC, and this will act as the VPC single ingress point and single egress point. And AWS will enforce a strict limit of one virtual gateway per VPC. So you're going to have a very clear, unambiguous routing boundary, which is going to make it a lot easier to deal with your networking. So, of course, the virtual private gateway will use BGP and dynamically propagate routes like you would in any other type of environment. These virtual gateways are fully managed and they are logical. So if you've ever worked with a loopback address on a router, which can't go down unless the router goes down, well, these virtual gateways don't go down unless the AWS cloud provider goes down. So they're pretty high availability by design. They can encrypt your traffic. And that means they can provide authentication of the traffic, integrity checking of the traffic, not the such that you're dealing with. So we've got a lot that we're actually getting here. So remember, there's lots of architectures we can talk about where we can use these typical environments and understand where they're transitive and non-transitive. So in this video, we covered what is AWS Direct Connect Gateway, what is AWS Transit Gateway, and AWS Virtual Private Gateway. We talked about how these gateways will fit into your overall cloud network architectures. Now, if you'd like to become an architect, like a cloud architect, network architect, security architect, cloud network architect, what have you, AI architect, we've got architectural programs to build your architecture career. Now, if you'd like to learn what it takes to become an architect, the skills that you need to become a cloud architect, enterprise architect, security architect, and how you can get hired as one, join me on the free How to Become an Architect, Ultimate Architect webinar. You can find that link in the description of this video. We'll go over the architecture roles. We'll talk about the skills you need and what you need to do to get hired. And of course, that'll be on Zoom, so you can ask me any questions you want, and I'll do anything I can to assist you in your architecture career. Now, if you've enjoyed this video, please give it a like. Subscribe to our channel and hit the bell to be notified of new videos to assist you in your cloud architect, network architect, security architect, or AI architect career. This is Mike Gibbs signing off for now, and I hope to see you in another architecture webinar or an architecture video. Take care.